All right, so yeah, I'm Jack Herrington, and I'm going to talk to you about local first semantic search. But before I do that, I do want to talk about Dan Stepanoff has the unenviable job of having my role tomorrow, finishing up the day. I know I'm keeping you guys from the after party, so I'm going to do this real fast, but he has just released the new Native Wind. Anybody use Native Wind? All right, cool. New version just came out today, dropped today, so check that out. All right, so I'm Jack Herrington. I have a YouTube channel called The Blue Collar Coder, and my thing is that I like to do lots of practical projects. So the practical project we're going to do here to create a local first semantic search with React Native is we're going to create a restaurant finder. So I've loaded up our app with a bunch of cool local restaurants, and I'll type in, like, say, for example, Italian, and we'll get Gabbiano's here. I don't remember, Gabbiano? Yeah? All right, cool. Okay, well, if you need a place for dinner, there you go. Okay, so how does this change? How is this different? How is semantic search different from like a keyword search? Well, a keyword search is, you have these descriptions, a bunch of text, use like a regex, you find the thing that you're looking for. But what happens if the term that you're looking for, like let's say you're looking for like Latin American food, none of the descriptions or none of the text has Latin in it. So what are you gonna do? Bring in AI. So what we're gonna do is we're actually gonna use AI, an AI model inside of our application. This is a web, sorry about that, but test bed for a semantic search engine. So there's different types of searching that you can do, including keyword search, but also semantic search using two different types of distance measurements. And it shows you if you were to take that text, which may or may not have Italian in it, it's gonna find certain terms that are somewhat connected to the term Italian. So that's how you go and you take a system that doesn't have the right keywords that you have for your search, but actually still find good results using an AI model. Okay, so in this we're gonna learn some good local restaurants like Gabbiano's, how to run AI in your React Native app, and some cool terminology so you can sound smart if you're out at Gabbiano's eating your pizza. And the first thing we're gonna learn is, first cool term is vector embeddings. So vector embeddings is a way you give your AI a vector embedding. So I might ask, like, what's a vector? Well, a vector is an array of numbers. So replace that with an array of numbers. Gives only a floating point number between -1 and 1, and you get a big number of these. These arrays are not small. There are, in our case, 384 numbers coming out of our AI. You can also get 768 and 1,536 when it comes to the bigger AI models, like the OpenAI models. But that doesn't explain what an embedding is. So an embedding imparts essentially a meaning to all those numbers, a semantic meaning. It captures something about the terms and turns it encodes that into essentially that number. And they are relatable when you talk about relations between those vectors. So let's say you have like cat, dog, and hat, and you'll see this anytime anybody talks about vector embeddings, talk about terms, simple terms like this, and how they compute into different vectors. And then when you think about those on a two-dimensional, so we're gonna take all those 384 coordinates or dimensions and flatten them into 2 dimensions. Like cat may appear up there, hat appears in an entirely different section because it's an entirely different kind of thing, but dog would be relatively close, so that's how you get your vector similarity, and you can use different measurements for that. So how are we gonna build our app? Well, it's gonna be 2 basic pieces. We're gonna create a search index, maybe at application startup time, or as we go and change the data in there, and we're gonna use that search index. So how do we create our search index? We load an embedding model, an AI model. We create an embedding for each one of those descriptions. We take that description, we just give it to the model, it gets back some numbers, and then we take that embedding and we put it into an index that gives us a fast retrieval between a new embedding that we get when we do the query and whatever vectors actually match coming out of that data. So first we gotta find a model. So we're gonna go over to Hugging Face, great name for a site, and we'll pick up the Snowflake Arctic Embed. an extra small size. The thing that we want is we want a text embedding inference engine. There are lots of different models for doing computer vision, for doing LLMs, for doing all of that. The one that we want is an AI for embedding. In particular, we want an Onyx model. So I'm actually the backup speaker, and I had a couple of days to throw this together. So I've tried to, when I was putting this all together, this is new to me. I'm not actually a React Native guy necessarily. I'm more a full stack guy. I'm not really an AI person either. But this is the one thing I could find that actually worked really well. Gant would say like, oh, you could do this with TensorFlow.js. I tried that, but it was slow. Anyway, I ended up with Onyx. I'm trying to figure that out. So you go into the Onyx section, there's a bunch of different models of different sizes. I'm sorry that you really can't see those numbers, but they range between like 90 megs and 23 megs, which I know is big for a native app. Anyway, you go and take one of them. In this case, I took the quantized 4 and I put that into our React Native app. So it comes in as an actual file in our app. That gives us our local first on-device AI. And then to use that, we're going to bring in the NPM module Onyx Runtime React Native from Microsoft. All right, so here's our code. Obviously, you can see that, right? Good. All right, let's jump in there. Okay, so the first part, that big number 1, was we were gonna go and build the index. So that function is gonna be called build index. And by the way, I'm gonna give you all the code for this. Gent and I are gonna figure out how to do that, but it's on GitHub and it's in my repository, Jahur, if you wanna go there. I think it's actually the first one currently. And so this build index is going to be what actually builds the index. So the first thing we need to do is load our asset. That would be that the Snowflake Onyx file that we just got. And then we use that Onyx Runtime React Native to create our inference session. So far, so good. But this is where it really starts to get interesting. And this is where I think you're gonna really benefit from this talk, because how many folks have actually interfaced with an AI, right? Cool, awesome. And you use, generally speaking, if you're an app developer or a web developer, you're using an API, right? And you give that API, say, some JSON, in this case, a prompt, Italian, and you get back some JSON, the numbers, and you imagine that inside of there somewhere, it's cracking open that JSON, getting out Italian, and then it's getting back some vector, and then it's packing that back up as JSON, sending it back out, right? Makes sense. So we're actually gonna end up doing the work of that API. We're gonna go take that model, we're gonna inject it in our app. Hello, there you go. This is like the coolest animation in the thing, and you're not working. What the heck? That's not right. Okay, so here's the problem. The problem is that you can't actually give Italian or any string to the AI. Well, because it doesn't take numbers. It doesn't take text. It takes numbers. So let's say you got like the query or the input string to our model is like Italian or Indian. What we really need to do is break that up into tokens and then turn those tokens into numeric values, because numbers, an array of numbers, is what the AI model actually speaks. In fact, the variable name or the input name for this particular input into the AI is input IDs. So how do I know that? Well, there's a really cool application called Netron that can actually go and visualize these Onyx models. And thankfully, on the right-hand side are all the inputs and the outputs. Cool. All right, so first we need the input IDs. Those are the actual text to number representations. Then there's an attention mask and a token type IDs. For our purposes, we can actually just use zeros for that. So now we know what the input model needs as opposed to text. And this is really cool, right? We have a much more intimate relationship with this model. We're actually replacing the API. We're learning more about how AIs work. So let's talk more about tokenization. So in this case, the particular AI was trained such that this per polynomial was like 17,505. It's this huge JSON file that has all of these mappings. So we need to use those JSON files then to turn our text into tokens. And the way that we do that is we use Zenova transformers. It's from, again, from Hugging Face. So lots of cool stuff coming out of Hugging Face for this. They have a set of tokenizers. If we look, it's not much nicer when we zoom in. You can get, for example, the auto tokenizer. We're not going to use that. We're going to use a pre-trained tokenizer. But you basically create the tokenizer, and then you just call tokenizer. You give it the text, and you get back the blessed input IDs that we're looking for. And we're going to fix our problem with talking to the AI. So we go back to our architect embed. We were looking at Onyx. Where do we find our tokenizer config? Well, it's down here. So we go and we take those. We pop those as assets into our program. And then back in our code, we then go and take those files, import them, create our predefined tokenizer. Then down in our build index, we create a new function called create embedding inside a closure. And we call that tokenizer, now that we've created it, with our text input. And we get back our input IDs, our attention mask. We send those on to our model, input IDs and attention mask, as well as our token type IDs, which are going to just set to 0. And now we fix our problem. No more problem. We're good. We can talk to the AI. Woo! All right, awesome. Except no. Sorry. The output isn't what we're looking for. We expect that we're just going to get a big one array of numbers. But what we get instead is we get this float 32 batch size, sequence length 384. So we know the 384, that's the vector size that we're looking at, or the, yeah, vector size. And batch size is 1, we're only giving a batch 1. But what the sequence length? Well, the sequence length is actually the number of tokens we put in. So for example, we put in great Italian food, we might get out these tokens, we get out those numbers. We get back actually 3 different vectors, 1 for each token. And that's actually really cool. I didn't know how to deal with that. Again, I'm not an AI guy, so I kept parsing through Python code, trying to figure out how this is done. Figured out eventually it's just you average every column. And that's actually one of the kind of things that you find out when you do this sort of stuff. Is like, ooh, actually it's a lot simpler than you'd think. But you essentially get the aggregate of all of those, and that becomes whatever the vector is for whatever text you put in as one big number. But that's actually where I got that idea to make that cool, really cool web visualization. And this is actually, when you think about it, like an interesting way to know if your AI, in this case, needs some tuning for your particular application. Like let's say you actually do want to do a restaurant embedding system where you do a really good search like this. You might want to actually visualize it to see, like, am I getting good values coming out of this? Like, does Italian actually map to the things that I think it should? So this is the kind of stuff that you only get to know if you actually understand AI at this level. Okay, so we get our last hidden state, that's the output. We do our global average. Global average is basically a simple little function that just takes some data. We create a new vector of that size, fill it with 0, add up all the numbers into it, divide it by the old mean thing, divided by the number of sequences, and there you go, that's our average. Okay, so now we have a create embedding. Yes, we can start actually implementing on this. So we've got our restaurants, they have an ID, a name, and a description. That's our data store. We're then gonna go and take that global average, and now we have our restaurants, and we can run our restaurants through that create embedding. And now we have a different problem. So now we actually have this really cool sort of in-memory database. It's got all of these rows, and these rows have IDs, 1, 2, and 3, say, the different restaurants with their different embeddings. Cool. But there's kind of a problem. Like, how do you actually search that in a fast way? Well, the answer is a really fun name. Like, this is like, oh man, gonna go to dinner tonight now and say, I know this really cool term. The term is hierarchical, navigable, meaning you got a data structure, you have the nodes in it, those nodes represent the vectors, you can then navigate between the different parts, the different planes of this data structure. Why you'd have to add that, I don't know. Seems like you'd want to navigate your data structure, right? Like, why would you even add that as a term? And then small worlds. Anybody play this game? Yeah, it's a good game, actually. not bad. I get the feeling that small worlds in this case, you can think of the different hierarchies as little worlds because all the vectors at each one of those levels, they're all essentially close to each other. So as you navigate down, you're trimming the search space so that you're just getting the distances between the nodes that are very closely related. And that's what you really want. You want what's called an approximate nearest neighbor search. And this hierarchical navigable small worlds index, or HNSW index, gives this to you really fast. And the cool thing is, you actually, coming out of this, know what vector databases are, because a vector database is this. It's that data structure that we just created with the embeddings, plus one of these HNSW indexes. So we're gonna use an off-the-shelf NPM module in-memory HNSW system. Gonna give it that data that we just got. Oh, I should say, let's take a look, there you go. That cosine at the end of there, that's actually somewhat interesting. When it comes to evaluating the difference, the distance between two nodes, you can do it multiple ways. You can use a cosine, where you're doing mainly a angular check between the two, or a Euclidean, which is essentially just the literal Euclidean distance or dot product distance. When it comes to embedding searches like this, cosine seems to be what everybody uses. So that's why that's there. So we build our index, and now, at the end of all this, we have our HNSW, and we got our way to create an embedding. Number one is done. Build index, we got it. Now we go and create it in memory. We go and create it, we initialize it with the data. And step one is done. Now we actually get to use it. So how do we use it? Well, we go and create an embedding from that query. We then find the nearest neighbors using our HNSW hierarchical navigable small worlds index. And then we return the nearest neighbors as the restaurants that we got back from that in scored order. So what that looks like in code is we have our next function, search restaurants. We give it our query string, we give it our number of results that we want. We then await our index. We get back our create embedding function that we then use to create the embedding. We then search that HNSW index that we got back. We get more results than we want because it's an approximate nearest neighbor search. So you might get some score variance, like you might get stuff that's actually lower score, up higher, and then you want to do a sort to sort that into the right order. Again, you're gonna work, aren't you? There you go. Oh. Okay, well, let's go back. Okay. Ah! There we go. Okay. This is a new clicker, but it's from Logitech. That's the problem. I used to live next to Logitech. I don't buy Logitech. Okay, so we sort our scores, and then we return back the restaurants. And that's it. That's all that search index does, and it is very, very fast. And we were talking about milliseconds here on a decent emulator. I haven't actually tried it in prod, of course. And let's take a look at our React Native code that actually uses this. So we got our home screen. I used Expo in this case. Is that good? Yeah? Okay. I don't know. It felt like Next, I guess. So that was good. Okay, so I'm going to use useState. I'll start it off with Asian Fusion, and then I'll use a use effect to go, and anytime I make the change, I'll go and call my search results function, or search restaurants function that I just created. Of course, again, you can just download this code and try it for yourself on your own data and see. We'll give it our search index, and then we'll get back our results. So we'll then go and put it into another useState. I mean, this all seems familiar, right? React Native is not all that different. And then down here at the bottom, we'll go and use, I can't remember what exactly UI library I did, but it has a list. The list, you give it a results, and a set of results and a render function, which is really cool. And then it goes and renders it for you. So shall I do a risky live demo? Yeah. Okay, sure, why not? Okay. Okay, anybody got any, what are you looking for here? Thai. T-H-A-I. There you go, hot yeah. This is good too. Heck yeah. Oh, I am? Oh, wait, what? Oh, no. There is? You guys are messing with me. That's not right. Hold on. It's cool, though. I can see stuff that you can't. Okay, here we go. So I want to mirror these things, I'm guessing? Yeah. Yeah. Do that. Okay, if I can find the mirror. This is why it's risky, right? Okay, advanced? Settings. Drag it to the other window? Okay, oh, that's an idea. Look at that. Okay. Okay, so now I need to know where the other window is. I think it's over here. Yeah, baby! Okay. All right. So, yeah, you asked for Thai. Oh, now I get to type over there. Okay. Thai. Did I get it right? Thai. Okay. All right. What? Another name? Another one? What? Spicy. Spicy food. Yeah. Okay. What do we get? Yeah, it is hot. I will give it that. What do we get? We also mole Mexican cuisine. That's probably pretty good too. So I don't know. I think it nailed it, right? Yeah. Okay. Yeah. Risky business accomplished. Okay. What was my last slide? Yeah, my last slide is just, hey, oh shoot, what the heck? Okay, there we go. Yeah, my last slide is just me. If you wanna follow me, I'm on X, Twitter, whatever you want to call it. LinkedIn, YouTube, @Jahur, basically all of this stuff that I talked about, practical examples of stuff. I will be moving more into like the React Native space, hopefully. Cool. As well as into AI, so I'm really looking forward to that. Looking forward to making more friends in the React Native space. Thank you for your time, and yeah, there you go, 5 o'clock, go party!